Now let's talk about geometric sequences. Previously, we have done arithmetic sequences, and now we'll move on to geometric. So what's the difference between an arithmetic and a geometric sequence? The only difference is that in an arithmetic sequence, we are adding or subtracting numbers, and in a geometric sequence, we are multiplying or dividing. Please note in a geometric sequence, we always refer to what we multiply by, even if we're dividing. So if, as an example, we are dividing by 3, that is the same thing as multiplying by 1/3. This is very important, and a lot of people make a mistake with this, which doesn't work well for them. So let's do an example. So 2, 4, 8, 16, 32. Nice and easy example. We already know from previously that 2, which is our first term, is our A. And now over here we notice, oh, okay, I can go and just say plus 2. But if I go and say plus 2 over here, then it should be 6. This would equal to 6. So what's happening? Something isn't working out here. Well, the thing is, now we are dealing with geometric sequences, so we cannot add numbers. We have to either multiply or divide. So let's do that. So let's try that, should I say. So 2 times something is equal to 4. We know that 2 times 2 is equal to 4. Now 4 times 2 is equal to 8. 8 times 2 is equal to 16, and 16 times 2 is equal to 32. So now we have gotten our constant difference. But since we're doing geometric sequences, this is no longer called a constant difference. No, this is known as the constant ratio. Now, you may be asking yourself, what is the general formula to create a sequence of a geometric sequence? This is it. Tn is equal to A multiplied by R n minus 1. As you already know, Tn is our number, A is our term 1, and now R is our constant ratio. I don't know why I put an N there, sorry. So now, based on this sequence, let's plug it into our formula and generate a formula for this geometric sequence. So Tn is equal to A is 2, our R is also 2, multiply all to the power of n minus 1. Now, please note, we can't go here and say that 2 times 2 is 4. But yes, 2 times 2 is 4, but we have to realize that we are working with exponents. So I implore you to refer to your BOD mass or bed mass, or literally whatever you use. I know some people use something called PEMDAS or whatever. Before we do multiplication, which is this step over here, we have to do our exponentiation. So that's why we leave it in this term, in this form. Well, now let's see if our formula is correct. So let's try T1, and we'll say T1 is equal to 2 times 2 multiplied by 1 minus 1, because this one and this one match up. Okay, so I know from BODMAS, BEDMAS, whatever, that 1 minus 1 is obviously 0. We have to do our exponents first, and anything to the power of 0 is 1. So this is just 2 times 1, which is 2. T2, let's try that. 2 times 2 all to the power of 2 minus 1. 2 minus 1 is 1. Anything to the power of 1 is the number itself. So 2 times 2 is 4. T3 is equal to 2 times 2, 3 minus 1. We know that will be 2 times 2 squared. 2 squared is 4. 4 times 2, or 2 times 4, is equal to 8. And just from the first few values over here, we can see that it matches up to what we have over here: 2, 4, 2, 4, 8, 2, 4, 8. So that is how you do a geometric sequence. Thank you.